Hello and welcome back. This is Jeffrey, and the topic we're going to be discussing today is linear functions. In this section, you'll learn to determine whether a linear function is increasing, decreasing, or constant. You'll also interpret slope as a rate of change, graph linear functions, and also determine whether lines are parallel or perpendicular to each other. Starting off with the basics, linear function. The equation form of linear function will be y is equal to mx plus b, and the function notation of that's going to be f of x is equal to mx plus b, where m is the slope and b is the y-intercept. Just a quick review, y-intercept means when x is equal to 0. Whatever that y value is, that's going to be the y-intercept. Okay, moving on to we're going to learn about determining whether a linear function is increasing, decreasing, or constant. So an increasing linear function will be when the slope is positive. So the opposite of that decreasing function is when the slope is negative. And we say a function is constant when the slope its m is 0. So just pretty easy. Function is increasing when the slope is positive, it's decreasing when the slope is negative, it's constant when the slope is 0. Interpret slope as a rate of change. So just know that the slope is equal to change in output over change in input. Basically, just remember that rise over run function. Okay, rise over run equation. So changing y over change in x is also the same as like 2 points. So like the first point minus the second point, or the second point minus the first point, doesn't matter. But you have to know that changing y, which is y2 minus y1, changing y over changing x, x2 minus x1, which is this change in x. So slope is also equal to f of x2 minus f of x1 over x2 minus x1. So graphing linear functions. So there are basically 3 ways you can graph a linear function. The first will be graphing the function by plotting in points. So how do you do that? Given a linear function, you'll have to graph by plotting points. You'll first choose a minimum of 2 input values, and then you evaluate the function at each input value. So you get the output, right? You get the output value, and then you use the resulting output values to identify the coordinate pairs. So you get like these pairs, right? Here it gives you 3 points, but really you just need 2. And then you use the result, and then you plot the coordinate pairs on grid and draw the line through the points. So yeah, after you got all the points, you just draw a line through them, making your linear function. So here's an example. If you want to graph the function of x is equal to negative 2/3 over 2/3 x plus 5 by plotting points, you begin by choosing input values. This function includes subtraction with the denominator of 3, so let's choose multiple of 3 as input values. And we will choose 0, 3, and 6. So when x is 0, y is going to be 5, and when x is equal to 3, y is also equal to 3, and when x is equal to 6, y is equal to 1. And then once you get the coordinate pairs, you just put them on graphs, right? And then you just basically draw a line that goes through all 3 these points. The second method you can use is using the y-intercept and slope. So given an equation for a linear function, graph the function using the y-intercept and the slope. So similarly, first you evaluate the function at an input value of 0 to find the y-intercept, right? So first find this point, that's going to give you your first point. Then you identify the slope as a rate of change of the input. Then you plot the point represented by the y-intercept. Then you use the rise over run equation to determine at least 2 more points on the line. And at last you can sketch the line that passes through the points. So basically, you first got this point, that's your y-intercept point, and then you use the slope, the rise over run, to find other points, and then you draw a line that goes through them. The last method is going to be just using transformations. So there are basically 2 things to remember. The first is vertical stretch over compression. The second is going to be just vertical shifting. So first, let's say you remember this function f of x is equal to x. It's going to be the purple line right here. And if you want to draw a line for, let's say, f of x is equal to 2x, you know that we're going to be vertically stretching the function f of x by a factor of 2, right? Because it's here. So you can draw that function, and then you notice that it's a blue line right here. And then if you're gonna vertically shift it upwards or downwards, you're just gonna be like literally shifting it upwards or downwards, given the values. And at last, determine whether the lines are parallel or perpendicular. So two lines are called parallel lines if they do not intersect at each other. So basically when their slope is the same. So if the m of the first equation, the first function is equal to the m of the second function, then they are called parallel lines. So basically m1, when m1 equals m2, they are parallel. And two lines are perpendicular to each other when two lines they do intersect to each other to form a right angle. So how do you find if two lines are perpendicular to each other? Just know the equation. When m1 times m2 is equal to -1, the two lines are called perpendicular lines. Okay. So here's the equation, and here's the equation for parallel, and here's for perpendicular. So let's do some practice question. First one is this function increasing, decreasing, or constant? I'll give you guys 30 seconds to work on this. Starting from now. Here's your answer. The first one is decreasing, and second one is constant. Wait. Oh, this should be decreasing. I don't know why it says increasing, but this should be decreasing and constant because the slope of this function is -2, so it should be decreasing. And because there is no slope, or the slope is 0, so for this second function, it is a constant, and that should be decreasing. Practice question number 2. Determine whether the lines are parallel or perpendicular to each other. I'll give you guys a minute to work on this, starting from now. Okay, here's your answer. The first one is parallel to each other, and the second one is perpendicular to each other. And here's why. Because the m for this and this are the same, right? They both got the slope of 7, positive 7, so they are parallel to each other. And for the second one, because m1, which is -1/2, times m2, which is 2, is going to be equal to -1. So these two lines are perpendicular to each other. And that's it for the lesson today. Thank you for listening.